Today we're going to go through several integral function AP problems. So the first one is from the 2012 exam. This is question number 3. So we've got this graph here, and it says let f be a continuous function defined on -4 to 3, whose graph consisting of 3 line segments and a semicircle at the origin is given above. And then we have our integral function, which is g of x is the integral from 1 to x, so always pay attention to the starting value of f of t. So we want the values of g of 2 and g of -2. So g of 2 is going to be the integral from 1 to 2 of f of t dt. Well, we're looking at from 1 to 2 is going to be this triangle here. So it's just going to be the area of the triangle. It's below the x-axis, so it's going to be negative. So this is going to be -1/2. The base of the triangle is going to be 1. And then the height, this goes down 1/2, so the slope is -1/2. So this distance is going to be 1/2. Okay, you can leave it just like this, but this is -1/4, but you can leave it unsimplified like that. For g of -2, that's going to be the integral from 1 to -2 of f of t dt. Okay, well, I'm going to rewrite this as negative the integral from -2 to 1. Okay, because it makes more sense to do the integral from the lower bound to the upper bound. So this is going to be negative, and then I'm going to do the areas starting from -2, which is here, on up to 1. Well, we've got this triangle, so that's going to be 1/2, 1 times its height's going to be 3. Okay, and then the semicircle below the x-axis, so that's going to be minus 1/2 pi r squared, the radius being 1. And again, you can leave it just like that. Okay, part B says for each g prime of -3 and g double prime of -3, find the value or state that it does not exist. Okay, well, g prime of x, if I take the derivative of this, is just going to be f of x. So g prime of -3 is going to be f of -3. So we go to the graph of f, we go to -3, and find that value is 2. Okay, g double prime of x is going to equal f prime of x. So d double prime of -3 is going to equal f prime of -3. So we go again to -3, and we want the slope here. So we're going up to over 2, so that slope is 1. Okay, next, find the x-coordinate of each point where the graph of g has a horizontal tangent line. For each of these points, determine whether it's relative minimum, relative maximum, or neither. At the point, justify our answers. So if we're looking for where it has a horizontal tangent, that we want the derivative, which in this case is f of x, to equal 0. Well, this happens at 2 different locations. It happens at -1, and it happens at 1. Okay, so what we're looking at here is the derivative. So from -1, it goes from positive to negative. So this is going to be, we go positive to negative, a local max. Because g prime of x switches from positive to negative. Okay, at x equals 1, it's 0, but it's going from negative to negative. So this is neither, because g prime does not switch signs. lastly, let f be a continuous function defined on negative 4, 3. So for D, it says for negative 4, 3, find all values for which the graph has a point of inflection. Graph of G has a point of inflection. Well, the second derivative of G is still the first derivative of f. Okay, and we want that. So we're looking at what's happening here. So when this switches signs, so this is going to occur whenever the graph of f switches from positive to negative. So that's going to occur at x equals negative 2. It's going to occur at x equals 0. And it's going to occur at x equals 1. Okay, because g double prime of x switches signs. Okay, or you can say f prime switches signs as long as you make that relationship. Okay, the second integral function problem I'm going to do is from the 2011 exam, and it is question number 4. So we've got a continuous function here. It's defined from negative 4 to positive 3. It consists of 2 quarter circles, so that quarter circle, and and one line segment. And g of x, and this is a little bit different, is 2x plus the integral from 0 to x of f of t. So first we're going to find g of negative 3. So that's going to be 2 times negative 3 plus the integral from 0 to negative 3 of f of t. Okay, so this is going to be negative 6, and then I'm going to make this the opposite of the integral from negative 3 to 0. So since this is positive, but we're reversing it, it's going to be negative, and then just the area of this quarter circle, so 1/4 pi 3 squared. Okay, now we're going to find g prime of x, so we'll take this derivative. That's going to be derivative of 2x is 2. Derivative of this is going to be f of x. And then we want to find g prime of negative 3. So that's going to be 2 plus f of negative 3, which is 0. So this is 2. Okay, so our next problem, determine the x-coordinate at the point at which g has an absolute maximum on the interval negative 4 to 3. So what we want to investigate is g prime of x, which we already established was 2 plus f of x, and we want that derivative to equal 0. So what we're looking for is when f of x is equal to negative 2, then g prime is 0. So if I look at my graph, it only is going to occur at one point right here, which is going to be halfway between 2 and 3. So when x is equal to 2.5. If we investigate this, it's going to be, we're adding positive until we get to that point. So the x-coordinate is just that 2.5. Okay, next we're going to find all values for which g has a point of inflection. So just like the last one, g double prime will just equal f prime. So we're looking for where f prime switches signs, which is only going to occur at x equals 0. Because g double prime of x, which equals f prime of x, switches signs. Okay, next, find the average rate of change of f on negative 4, 3. That's going to be f of 3 minus f of negative 4 over 3 minus negative 4. So using the graph, f of 3, 1, 2, 3, is negative 3. F of negative 4 is negative 1. Okay, and you can simplify it or leave it just like that. Then it says there is no point between negative 4 and 3 for which the derivative f prime at C is equal to the average rate. Explain why this statement does not contradict the mean value theorem. Mean value theorem says the slope of the secant line equals the slope of the tangent line somewhere as long as the graph is differentiable, and it is not. It is not differentiable at two locations. It's not differentiable here, where there's an abrupt change. It's also not differentiable here, where there's going to be a vertical asymptote. So that violates the mean value theorem, which says it has to be continuous and differentiable.